Right now, as you're watching this, something extraordinary is happening in our solar system. An ancient visitor from another star system, moving at 200,000 kilometers per hour, is being bombarded by a massive cloud of plasma ejected from our sun. The collision is happening at this very moment, and we can't see it. The object has vanished behind the sun, invisible to every telescope on Earth and in orbit. This isn't science fiction. This is 3I Atlas, the third confirmed interstellar object ever detected passing through our solar system. And it just became the center of something unprecedented. NASA has activated its planetary defense protocols for the first time against an object from beyond our solar system. Let me tell you what's happening right now, 200 million kilometers away, on the far side of our star. October 23rd, 2025. Russian astronomers at the Laboratory of Solar Astronomy detected one of the most powerful solar explosions in recent history. The blast occurred on the far side of the sun, hidden from Earth's view. They estimated the power at X10 class, maybe higher. To put that in perspective, an X10 flare is 10 times more powerful than an X1, and X-class flares are already the most intense category we have. The explosion hurled billions of tons of superheated plasma into space at speeds approaching 2 million kilometers per hour. But here's what made this different. The plasma cloud wasn't heading toward Earth. It was aimed with almost pinpoint accuracy, within 10 to 20 degrees, directly at the position where 3I Atlas would be. The astronomers calculated the trajectory. Impact time, approximately 3 p.m. Moscow time, October 24th, 2025. The comet would remain inside the plasma cloud for at least 36 to 48 hours. Think about that timing for a moment. A massive solar explosion occurs exactly when this interstellar visitor is positioned perfectly to intercept it. The Russian scientists joked darkly in their report. Let's see how the aliens handle being weather sensitive. In H.G. Wells's War of the Worlds, nature only needed common flu viruses. Now, whether you believe 3I Atlas is an alien probe or a natural comet, something very strange is about to happen. A 7 to 10 billion year old object, older than our sun, is being hit by a wall of charged particles traveling at incredible speeds. What will this do to it? Will it destroy the object? Activate something? Change its trajectory? We don't know. And that uncertainty is exactly why NASA did something it has never done before. On October 23rd, NASA and the International Asteroid Warning Network officially activated their Planetary Defense Observation Campaign, not for an asteroid threatening Earth, for 3I Atlas. The announcement was carefully worded, talking about unique challenges the object presents and the opportunity to conduct global exercises with tracking systems worldwide. But read between the lines. This is the first time in history that Earth's early warning system has been formally activated for something that came from another star. The official document mentions that 3I Atlas behaves anomalously, complicating trajectory calculations. That's NASA speak for this thing isn't following the rules. And when you look at what this object has done since it arrived, you start to understand why people are nervous. Let's go back to the beginning. July 1st, 2025. The Atlas telescope system in Chile, designed specifically to spot potentially dangerous asteroids, picked up a new object. At first, nothing seemed unusual. Comets and asteroids are discovered regularly. But within hours of calculating its orbit, astronomers realized something was off. The trajectory was hyperbolic, meaning this object wasn't bound to the sun's gravity. It came from somewhere else. This was only the third confirmed interstellar visitor in human history. The first was Oumuamua in 2017, that bizarre cigar-shaped object that accelerated unexpectedly and sparked endless speculation. The second was Borisov in 2019, which looked reassuringly like a normal comet. And now, 3I Atlas, except this one is different from both predecessors in almost every measurable way. The object is enormous. Initial estimates put the nucleus between 2 and 6 kilometers across. That's not the gas and dust cloud surrounding it. That's the solid core. To give you a sense of scale, that's roughly the height of Mount McKinley, compressed into a near spherical shape, made of ice, rock, and frozen gases, with a total mass estimated at 30 billion tons, traveling at 210,000 kilometers per hour relative to the Sun. Now here's where it gets interesting. By all the rules of cometary physics, 3I Atlas should be completely dormant at its current distance from the Sun. It's currently at about 3 astronomical units, roughly the distance between the Sun and the asteroid belt. At that range, there isn't enough solar heating to vaporize water ice. Comets typically don't wake up until they get inside 2AU. Some don't activate until they're practically kissing the Sun's surface. But 3I Atlas is producing water vapor, 40 kilograms per second. That's the equivalent of filling a large bathtub every single second, continuously. And it's doing this at a distance where the Sun's warmth should barely register. When NASA's Swift telescope observed the object in October, the readings didn't make sense. Water production at 3AU shouldn't be possible unless something is generating internal heat. But what? Comets don't have internal heat sources. They're inert chunks of frozen material. So what's powering this? There are theories. Maybe the comet is rich in highly volatile substances, like carbon monoxide, that sublimate at much lower temperatures. Maybe there's some kind of chemical reaction happening inside. Maybe it's structural, cracks exposing fresh ice to even weak sunlight. Maybe it captured heat during a close stellar encounter millions of years ago and is still slowly releasing it. Or maybe, as some suggest, it's not a comet at all. That suggestion comes from someone you might know. Avi Loeb, the Harvard astrophysicist who became famous, or depending on your view, infamous, for suggesting Oumuamua might be an alien probe. Loeb has been studying 3I Atlas intensely, and he points to several features that don't fit the natural comet hypothesis. The perfectly timed trajectory that brings it past 3 major planets. The unusual chemical composition, the water production anomaly, and something else that most people haven't heard about yet. The object's acceleration pattern doesn't quite match what you'd expect from outgassing alone. When comets heat up and vent material, that creates thrust, like a rocket engine. This is called non-gravitational acceleration, and it's completely normal. But 3I Atlas's acceleration pattern is too smooth, too consistent. Natural outgassing is chaotic and uneven. This looks almost controlled. Loeb suggests the object might be using a technique called an Oberth maneuver, a real spaceflight technique where you use a close pass by a massive object to change velocity and direction efficiently. The idea is that 3I Atlas swung around the Sun at perihelion, using our star's gravity well to alter its course with minimal energy expenditure. That's exactly what spacecraft do. But comets don't do this deliberately. They don't plan their trajectories. Unless, of course, something else is going on. Now, I want to be very clear here. The mainstream scientific consensus is that 3I Atlas is a natural object, an ancient comet from another star system. Most astronomers disagree with Loeb's interpretation. They point out that we're still learning about interstellar objects, and what seems anomalous now might just reflect our incomplete understanding. Every unusual feature probably has a natural explanation we haven't discovered yet. But Loeb makes one point that's hard to dismiss: the timing. 3I Atlas arrived during perihelion season, positioned its closest approach to the Sun for late October, and will remain behind the Sun, hidden from Earth's view, for weeks. Its trajectory takes it past Mars, where it made its closest approach on October 3rd, then Venus in early 2026, then Jupiter later that year. Almost like it's on a planned tour of the solar system's major worlds. Is that just coincidence? Probably. Space is big. Orbits are complex, and humans are pattern-seeking creatures who see intention where none exists. But it's worth noting that of all possible trajectories through our solar system, 3i Atlas chose one that maximizes close encounters with planets while minimizing observation opportunities from Earth. And now, at this exact moment in its journey, when it's behind the sun where we can't see it, it's being hit by one of the most powerful plasma clouds in recent solar history. The charged particles are washing over the object right now. If it's a natural comet, the plasma might erode surface material, trigger more outgassing, even fragment the nucleus if it's structurally weak. If it's something else, well, who knows what might happen? The Russian astronomers joked about testing alien weather sensitivity. But jokes aside, this is an incredible natural experiment. We have an object from another star system, possibly billions of years old, being subjected to extreme conditions we can directly measure. When 3i Atlas emerges from behind the sun in mid-November, we'll be watching very carefully. Will it look different? Will its composition have changed? Will the water production increase, decrease, or stop entirely? Will its trajectory shift in unexpected ways? These are questions we've never had the opportunity to ask before. Now let me tell you what makes 3i Atlas truly different from anything we've seen before. It's not just the behavior. It's what this thing is made of, and when it was made. When the James Webb Space Telescope turned its infrared eyes toward 3i Atlas in September, scientists expected to see a familiar pattern. Comets from our solar system have pretty consistent compositions. Lots of water ice, some carbon monoxide, carbon dioxide, methane, ammonia. The ratios vary, but there's a typical range. 3i Atlas doesn't fit that range. Not even close. The comet is producing carbon dioxide at 8 times the rate of water vapor. 8-to-1. That's not a slight variation. That's a completely different category of object. In our solar system, even the most CO2-rich comets max out at maybe 2 or 3-to-1. Most are the opposite, water-dominant with just traces of carbon dioxide. This thing is fundamentally backwards from what we expect. What does that tell us? It means 3i Atlas formed in a very different environment than our comets. The ratio of gases frozen into a comet depends on the temperature and pressure conditions where it formed, and on the chemistry of the protoplanetary disk. A comet with 8 times more CO2 than water formed in a region that was simultaneously hot enough to bake off water, but cold enough to trap carbon dioxide. That's a very specific set of conditions. Scientists describe 3i Atlas as baked and boiled. Imagine a young star system, maybe a larger, hotter star than our sun. In the inner regions, temperatures are so high that water doesn't condense easily. It remains as vapor and gets blown away by stellar winds. But further out, in a zone that's still relatively warm by our standards, carbon dioxide can condense. The protoplanetary disk in this region would be carbon-rich, almost the opposite of what we see in our own solar system's formation zone. This suggests 3i Atlas came from a stellar neighborhood nothing like ours. A different class of star, probably. A different chemical makeup in the original molecular cloud. When this object formed 7 to 10 billion years ago, it carried with it the chemical fingerprint of an alien stellar environment. And that fingerprint is still readable today, billions of years later, preserved in the frozen gases locked in its interior. 7 to 10 billion years old. Let that number sink in for a moment. Our sun is 4.6 billion years old. Earth is 4.5 billion. The oldest rocks we've found on Earth are about 4 billion years old. This comet predates our entire solar system by 3 to 5 billion years. How do we know this? Trajectory analysis. By tracking 3i Atlas's motion very precisely and calculating backwards, astronomers can trace its path through the galaxy, not just where it came from recently, but its entire orbital history around the Milky Way. The calculations show that this object has been wandering through interstellar space for an unimaginable length of time. It's not a recent ejection from a nearby star system. It's ancient. A relic from the early universe, when the galaxy was young. 10 billion years ago, the universe itself was only 3.5 billion years old. The Milky Way was still forming. Star formation was happening at a much higher rate than today. Heavy elements were less abundant. The galaxy was a more chaotic, violent place. And somewhere in that ancient chaos, in a solar system that no longer exists, this comet formed. The star it originally orbited is probably dead now. It might have been a massive star that burned through its fuel quickly and went supernova billions of years ago. Or maybe a sun-like star that's now a white dwarf, slowly cooling in some distant part of the galaxy. We'll never know. The system that birthed 3I Atlas is lost to time, but the comet remains, a frozen time capsule from an era we can barely imagine. Here's the really mind-bending part. This object has been in deep freeze for most of its existence. In the void between stars, temperatures hover just a few degrees above absolute zero. Cosmic rays bombardment causes some damage over billions of years, but the cold preserves. Ice doesn't sublimate in the void. Chemical reactions essentially stop. The comet was in cryogenic storage, perfectly preserved, for longer than our solar system has existed. But that creates a paradox. If 3I Atlas has been frozen for billions of years, why is it so active now? Why is it producing 40 kilograms of water per second at a distance where it should be dormant? Ancient ice should be depleted of volatiles. The most reactive materials should have been stripped away by cosmic rays. By all rights, this should be a dead, inert rock with maybe a thin coating of ice. Instead, it's acting like a fresh, young comet. Unless it's not as old as the trajectory suggests. There's an alternative theory. Maybe 3I Atlas is old material that was recently liberated from a larger body. Imagine it was part of a planet, or a Pluto-sized dwarf planet orbiting some distant star. Something catastrophic happened. Maybe a collision. Maybe a close encounter with a massive object. And chunks of this ancient world were ejected into interstellar space. Those chunks retained their original composition, their ancient chemistry, but they're structurally young, freshly broken. This would explain the activity. Fresh fractures expose interior ice that hasn't been processed by cosmic rays. The surface might be ancient, but just below is pristine material that behaves like it's newly formed. The age and the activity aren't contradictory if the comet was recently created from ancient ingredients. But recently in cosmic terms could still mean millions of years ago. We don't know. What we do know is that 3I Atlas carries within it a record of a stellar environment vastly different from our own, from an era when the galaxy was young. That alone makes it one of the most scientifically valuable objects ever detected. And it's not alone. This is the third interstellar visitor we've found, but the three couldn't be more different from each other. That diversity tells us something profound about the galaxy. Oumuamua, the first, arrived in 2017 and broke every rule we had for comets. It was shaped like a cigar or a pancake, depending on which model you believe. About 400 meters long. It showed no sign of outgassing, no coma, no tail. Yet it accelerated slightly as it left the inner solar system, as if something was pushing it. That acceleration sparked years of debate. Was it outgassing we couldn't detect? Solar radiation pressure on an unusually reflective surface? Or, as Avi Loeb suggested, could it be a light sail, a piece of alien technology? The controversy never really resolved. Oumuamua left the solar system before we could study it properly. It's now beyond the reach of any telescope, racing away at 26 kilometers per second. We'll never know what it really was, but it taught us that interstellar objects might not look like anything we expect. Then came Borisov in 2019, discovered by an amateur astronomer in Crimea. Borisov was almost reassuringly normal. It looked like a comet. It acted like a comet. It had a coma, a tail, outgassing that matched predictions. Scientists could study it properly, and what they found was both familiar and alien. Borisov had unusually high carbon monoxide compared to solar system comets, but not outrageously so. It was just different enough to be clearly from somewhere else, but similar enough to be recognizable. Borisov gave us confidence that we understood comets, that the physics was universal even if the chemistry varied. It was the control group, the baseline. And then 3I Atlas arrived and threw everything into chaos again. Look at the comparison. Oumuamua, rocky or metallic. No volatiles detected, bizarre shape, mysterious acceleration. Borisov, icy comet, high CO, normal behavior. 3I Atlas, icy comet, extreme CO2, ancient age, anomalous activity, perfect planetary tour trajectory. 3 visitors, 3 completely different profiles. What does this diversity mean? It means planetary systems across the galaxy are wildly varied. Different star types, different formation conditions, different chemical abundances all produce different populations of comets and asteroids. We've only seen 3 samples, but they suggest incredible complexity out there. Thousands of types of objects we haven't imagined yet, and thousands are passing through our solar system undetected. The statistics are humbling. Based on detection rates, astronomers estimate that dozens or hundreds of interstellar objects pass through the inner solar system every year. Most are too small or too far away to spot. Our detection systems only catch the closest, largest ones. For every Oumuamua or 3I Atlas we find, countless others slip past invisibly. Future survey telescopes will change that. The Vera Rubin Observatory, scheduled to begin operations soon, will have the sensitivity to detect interstellar objects much smaller and more distant than current systems. We might go from finding 1 per year to 1 per month, or even 1 per week. Each one will be a messenger from a different stellar environment, carrying information about planetary systems we'll never visit. But 3I Atlas might be carrying something more than just information. It might be carrying the ingredients for life itself. When astrobiologist Dennis Budowitz analyzed the spectroscopic data from 3I Atlas, he made a striking observation. The comet contains water, carbon compounds, and likely organic molecules. Not life, but the chemical building blocks life requires. And here's the key point. These ingredients are not unique to our solar system. They exist in comets from other stars. That means the chemistry necessary for life is common across the galaxy. This shouldn't surprise us. We've found organic molecules in interstellar space, in other star systems, even in the atmospheres of planets around distant stars. But there's something different about finding them in an intact object that traveled here from another system. It's like receiving a package from another world, and when you open it, you find the same materials that built Earth's oceans and seeded life on our planet. Because that might be exactly what happened here. There's a hypothesis, an old idea that's gaining new respect, called panspermia. The suggestion that life's building blocks, or maybe even life itself, can spread between worlds on comets and asteroids. A comet impacts a planet, delivering water and organics. Over millions of years, chemistry happens. Molecules become more complex. Eventually, somehow, life emerges. We know comets delivered material to early Earth. The debate is over how much. Some scientists think most of Earth's water came from comets. Others argue it was mostly from asteroids, or was present in the original material that formed the planet. But everyone agrees comets contributed something. And if comets from our own system helped build Earth, then comets from other systems could have seeded life on planets around other stars. 3I Atlas is proof that the process works in reverse, too. Material from alien star systems can reach our solar system intact. The journey takes millions of years, but it's possible. And if it's possible in one direction, it's possible in both. Maybe life's ingredients have been spreading through the galaxy for billions of years, carried on ancient comets like this one, seeding world after world with the chemistry needed to start the long road to complexity. Now, I want to be very careful here. 3I Atlas is not carrying life. The radiation environment in interstellar space is far too harsh. Cosmic rays would shred any complex molecules or biological structures over millions of years. Even simple organic compounds are damaged, though some can survive. So we're not talking about living organisms hitchhiking between stars. We're talking about chemistry, raw materials, the ingredients that might, under the right conditions, lead to life. But here's where it gets interesting again. 3I Atlas is 7 to 10 billion years old. It formed when the universe was young, and it's been wandering the galaxy ever since, possibly passing through dozens or hundreds of star systems, maybe more. What if, billions of years ago, this comet passed close to a young planet in a habitable zone? What if it delivered its cargo of water and carbon compounds to a world where conditions were just right? That world could have developed life billions of years ago. That life could have evolved, become complex, maybe even intelligent. It could have risen and fallen, leaving no trace, all while 3I Atlas continued its endless journey. And now that same comet is here, in our solar system, being studied by the descendants of whatever chemistry happened on Earth 4 billion years ago. It's a strange thought. This object is a thread connecting deep time and vast space. It links the early universe to the present day, and potentially connects our world to others we'll never see. And right now, it's being bombarded by plasma from our sun, hidden behind the star where we can't watch what happens next. So why did NASA activate planetary defense protocols for an object that poses no threat to Earth? That's the question everyone's asking, and the official answers are carefully constructed to avoid causing panic while also avoiding outright lies. The public statement says 3I Atlas presents unique challenges for tracking and prediction. It talks about using this opportunity to test international coordination, to exercise the Global Observation Network, to refine techniques for monitoring fast-moving objects with uncertain trajectories. All of that is technically true. But it's not the whole story. Here's what the official document actually says, and I'm quoting directly. Due to unique problems which 3I Atlas creates, global exercises will be conducted. Unique problems, not unique opportunities. Problems. And when you look at what those problems are, you start to see why there's concern. The first problem is trajectory prediction. Every object in space follows predictable paths, determined by gravity and momentum. We can calculate where a comet will be years in advance with extreme precision. But 3I Atlas keeps defying predictions. Small deviations, yes, but consistent ones. The object is not quite where it should be, and the errors don't fit the expected pattern from normal outgassing. Tom Statler, NASA's lead researcher on this project, has been very careful in his public statements. He maintains that everything observed is consistent with natural comet behavior, just unusual natural behavior. But privately, according to reports from astronomers involved in the observation campaign, there's significant debate about what's causing the trajectory anomalies. Normal comets produce jets of gas and dust when they heat up. These jets are asymmetric. They sputter and pulse. They create chaotic forces that push the comet in unpredictable directions. 3I Atlas's thrust pattern is different. It's steadier, more directional, almost like someone or something is making small course corrections. Avi Loeb points to this as evidence of artificial control. He notes that the trajectory brings 3I Atlas remarkably close to 3 major planets in succession. October 3rd, closest approach to Mars at just over 20 million kilometers. That's close enough that the comet passed through Mars's extended magnetosphere, the region where the planet's magnetic field interacts with the solar wind. Then, in early 2026, a pass by Venus, then Jupiter later in the year. What are the odds of that happening by chance? Actually, not as low as you might think. Planetary alignments happen regularly, and any object passing through the inner solar system will likely approach multiple planets. But the precision is interesting. Each encounter is close enough for detailed observation, but not so close as to significantly alter the comet's trajectory. If you were designing a probe to survey the solar system's planets, this is approximately the route you'd choose. And then there's the hiding. 3i Atlas is currently behind the Sun from Earth's perspective. It will remain there until mid-November, a period of several weeks when direct observation is impossible. The comet entered solar conjunction at almost exactly the time when the plasma cloud hit it. Whatever is happening right now, whatever effects that massive dose of charged particles is having on the object, we can't see it. Some spacecraft can observe the far side of the Sun. The Solar Orbiter, for instance, a European Space Agency probe studying the Sun from various angles. But Solar Orbiter is currently on the opposite side of its orbit. It's looking at the same hemisphere of the Sun that Earth sees. The far side, where 3i Atlas is located, has no direct observers. We're relying on indirect measurements, on observations from Mars' orbit, on predictions and models. The last clear observation of 3i Atlas was in early October. The next opportunity for direct viewing from Earth won't come until mid-November, about 5 weeks of blindness. And NASA is very interested in what condition the object will be in when it reappears. This is where the planetary defense exercise becomes relevant. NASA has asked observatories worldwide to prepare for intensive monitoring when 3i Atlas becomes visible again. Every major telescope that can be spared will be pointed at this object. Radio telescopes, optical telescopes, infrared, ultraviolet, X-ray. The full spectrum. They want to know immediately if anything has changed. What kind of changes are they looking for? The public statements mention composition, outgassing rates, structural integrity, but the private priority list, which has leaked through various channels, includes some interesting items. They want to measure the object's rotation rate very precisely to see if it's changed. They want to look for any new emissions, any wavelengths that weren't present before. They want to check if the trajectory prediction errors have increased, decreased, or remained constant. And they want to know if the object is communicating. That last item isn't in any official document, but multiple astronomers involved in the planning have confirmed that radio observations are a priority, not just measuring the object's thermal emissions, which is standard procedure. They're specifically looking for narrowband signals, coherent transmissions, anything that might indicate artificial radio sources. This is unprecedented. NASA has never publicly stated it's searching for technosignatures from a specific object in our solar system. SETI, the search for extraterrestrial intelligence, looks at distant star systems. But 3i Atlas is here, right now, close enough to study in detail. If there was ever an object worth checking for artificial signals, this is it. Now, before anyone gets too excited, let me be clear about what's actually likely to happen. The most probable outcome is that 3i Atlas will reappear in November, looking slightly different than it did in October, in ways entirely consistent with being pelted by high-energy particles for 2 days. The outgassing might be stronger or weaker. The surface might be more eroded. The coma might have changed shape. These are all normal effects of plasma bombardment. We'll learn something interesting about comet physics, especially for interstellar comets that might have different compositions than solar system ones. And life will go on. But there's a non-zero possibility that something unexpected will happen. That's what NASA is preparing for, and that's what makes this so fascinating. Think about what we know so far. An object that predates our solar system by billions of years. Extreme chemical composition, unlike anything in our own stellar neighborhood. Water production at impossible distances. Trajectory that perfectly tours the major planets. Acceleration patterns that don't quite fit natural explanations. And now it's been subjected to an intense plasma bombardment at exactly the moment when it's hidden from our view. Either this is a remarkable series of coincidences involving a natural object that happens to behave strangely in multiple ways, or something else is going on. And NASA, despite its official position that this is certainly a natural comet, is hedging its bets. The planetary defense exercise is real. The international coordination is real. The priority assigned to this object is higher than any comet in history. Why? Because if there's even a 1% chance that 3I Atlas is not what it appears to be, the implications are too important to ignore. This object came from another star system. It's older than Earth. It's behaving in ways we don't fully understand. And it's in our backyard right now, close enough to study, close enough to potentially interact with, if we chose to do so. The Oberth maneuver that Avi Loeb mentions is particularly interesting in this context. For those unfamiliar, it's a real orbital mechanics technique used by spacecraft. When you're deep in a gravity well, your velocity is very high. If you fire your engines at that moment, at perihelion, when you're moving fastest, you get more change in total energy than if you fire them elsewhere in your orbit. It's counterintuitive, but mathematically proven. Every interplanetary mission uses Oberth maneuvers to maximize efficiency. The suggestion is that 3I Atlas performed an Oberth maneuver around the Sun, using perihelion in late October to adjust its trajectory with minimal energy expenditure. This would require planning. It would require thrust at a specific time and direction. Natural comets don't do this. They outgas chaotically whenever they're hot enough. But a controlled object, a probe, would use exactly this technique to maximize fuel efficiency. Is that what happened? We don't know. We won't know until November, when the object is visible again, and we can see if the trajectory has changed in ways that match the Oberth prediction versus natural outgassing. But the fact that NASA is specifically looking for this tells you they're taking the possibility seriously. There's another aspect to this that hasn't received much attention: the plasma bombardment itself. When charged particles hit an object at high speed, they deposit energy. They cause heating. They can trigger electrical discharges. If 3I Atlas were purely a natural comet, the plasma would erode surface material and trigger outgassing. We'd expect to see a bright tail, increased activity, maybe even fragmentation if the structure is weak. But what if it's not purely natural? What if there are artificial components, shielded electronics, power systems, anything that might respond to a massive injection of electrical energy? The plasma cloud from the Sun is essentially a giant electromagnetic pulse. It's natural EMP, billions of times more powerful than anything humans have created. If there's dormant technology inside 3I Atlas, this could be the equivalent of plugging it in. I'm speculating now, obviously. But it's speculation that fits the known facts. An ancient object from another star system, possibly containing preserved technology from a civilization billions of years old, receives a massive energy injection at exactly the moment when we can't observe the results. And NASA responds by activating planetary defense protocols and coordinating a global observation campaign for when it reappears. The Russian astronomers joked about testing alien weather sensitivity. Maybe that's all this is, a natural comet having a bad day. But maybe, just maybe, we're about to witness something that's never happened before in human history. First contact, not from a distant radio signal, but from a visitor that came to us. In about 3 weeks, we'll start getting answers. Mid-November, 3I Atlas emerges from behind the Sun. Every telescope on Earth and in orbit will be watching. The data will start flowing in immediately. Within hours, we'll know if anything fundamental has changed. Within days, we'll have detailed spectroscopy, trajectory measurements, radio observations. Within weeks, we'll have a complete picture of what the plasma bombardment did to this object. And then we'll know. One way or another, we'll know if 3I Atlas is just an unusually weird comet, or if it's something more. The waiting is the hard part. But that waiting is almost over. So what exactly will happen when 3I Atlas reappears? Let me walk you through the observation plan, because it's unlike anything attempted before for a comet. The moment the object clears solar conjunction and becomes visible from Earth, a coordinated global campaign begins. It's been organized through the International Asteroid Warning Network, but this goes far beyond their usual scope. Dozens of observatories on 6 continents, plus orbital assets, all synchronized to capture data simultaneously. First priority is position and trajectory. Multiple radar facilities will ping the object to get precise range and velocity measurements. Arecibo is gone, destroyed by that tragic collapse in 2020, but the Green Bank Telescope in West Virginia has radar capability. So does Goldstone in California, part of NASA's Deep Space Network. The European Space Agency's tracking stations will contribute. Even some military installations are reportedly participating, though that's not publicly confirmed. Why such emphasis on trajectory? Because any deviation from predictions tells us something crucial. If 3I Atlas is exactly where natural orbital mechanics says it should be, accounting for known outgassing effects, that supports the comet hypothesis. But if there are additional velocity changes, unexpected course corrections, anything that doesn't fit the model, that raises questions, and if those changes match what you'd expect from an Oberth maneuver performed at perihelion, well, that's when things get very interesting. Second priority is spectroscopy. This is where we learn what the object is made of and whether that's changed. The James Webb Space Telescope will dedicate observation time, which is remarkable considering how oversubscribed that instrument is. Hubble too. Ground-based observatories with high-resolution spectrographs, like Keck in Hawaii, and the Very Large Telescope in Chile, are scheduled for multi-night observation runs. They'll be looking at the gas and dust being emitted. Water vapor, carbon dioxide, carbon monoxide, all the usual suspects, but also unusual molecules. The earlier observations showed that strange 8-to-1 CO2 to water ratio. Has the plasma bombardment changed that? Has it triggered outgassing of materials that weren't active before? Are there any unexpected emission lines in the spectrum, wavelengths that don't correspond to known molecules? This last point is particularly important. If you wanted to signal that an object is artificial, embedding unusual spectral signatures in its outgassing would be one way to do it. Not radio signals that require receivers and electronics. Just chemistry, but chemistry that doesn't occur naturally. We'd recognize it immediately as anomalous, as deliberately constructed. It's a far-fetched idea, but it's on the list of things they're checking. Third priority, and this is the one that's generated the most speculation, is radio observation. The Arecibo Observatory would have been perfect for this, but we have alternatives. The Very Large Array in New Mexico, configured for maximum sensitivity. The ALMA Array in Chile. The Meerkat Telescope in South Africa. Even the massive 500-meter aperture spherical telescope in China, FAST, is reportedly participating. What are they listening for? Officially, thermal emissions. All objects radiate heat, and the wavelength distribution tells you about temperature and composition. That's standard astronomy. Unofficially, they're looking for anything that shouldn't be there. Narrowband signals, repeating patterns, modulation that suggests information encoding. The SETI protocols, basically, but applied to an object in our solar system rather than a distant star. The chances of detecting anything are vanishingly small. Even if 3I Atlas were artificial, why would it be transmitting radio signals? And even if it were transmitting, why in frequencies and formats we'd recognize? The object is potentially billions of years old, from a civilization we can't imagine. Any technology would be so advanced, so alien, that we probably wouldn't recognize it as technology at all. But you check anyway, because if there's even a microscopic possibility of confirmation, the implications are too significant to ignore. This would be the most important discovery in human history. Proof that we're not alone. Proof that intelligence can arise elsewhere, can build things, can send them across the galaxy. Everything changes with that knowledge. Now, let's consider the possible outcomes when the data starts coming in. I see 4 basic scenarios, ranging from mundane to world-changing. Scenario 1. Everything is normal. 3I Atlas looks slightly different, as you'd expect after plasma bombardment. The composition is consistent with earlier observations. The trajectory matches predictions within acceptable margins. The outgassing has increased or decreased based on heating effects and surface erosion. Radio observations show only thermal emissions. Spectroscopy reveals nothing unexpected. NASA issues a report concluding this was a valuable opportunity to study an interstellar comet. We learned a lot about how such objects behave, and life goes on. This is the most likely outcome by far. Scenario 2. Something interesting, but explainable. Maybe the plasma bombardment triggered unexpected chemical reactions, creating molecules we haven't seen in comets before, but which makes sense given the extreme conditions. Maybe the trajectory shows small anomalies that can be explained by asymmetric outgassing with unusual composition. Maybe there's a structural change, a crack or fragment, that makes the object look different, but is entirely natural. We'd have papers and conferences and debates about the details, but no fundamental paradigm shift. Still a natural comet, just a weird one that taught us something new. Scenario 3. Something unexplained but not conclusive. This is where it gets uncomfortable. Imagine the trajectory has changed in ways that don't fit natural models, or the spectroscopy shows emission lines that don't correspond to any known molecule or atomic transition, or there are radio signals that have structure but aren't quite convincing as artificial. We'd have a mystery. Scientists would argue about interpretations. Some would insist there must be a natural explanation we haven't found yet. Others would point to the accumulation of anomalies as evidence of something more. It would be frustrating because we'd know something is different, but we wouldn't know what or why. And 3I Atlas would continue its journey, leaving the solar system before we could gather more data. Scenario 4. Unambiguous. Clear evidence that cannot be explained by natural processes. Maybe the object changes its trajectory in a way that requires controlled thrust at specific times. Maybe there's a radio transmission that contains obvious patterns, prime numbers or mathematical constants, or something equally unlikely to occur naturally. Maybe the spectroscopy shows materials that couldn't form in any known stellar or planetary process. Whatever the specific evidence, it's compelling enough that the scientific consensus shifts from probably natural to possibly artificial. This would be the discovery of the millennium. The implications would be staggering, and humanity would face questions we're not prepared to answer. How do we respond to confirmation of alien technology? Do we try to communicate? How? The object is moving at 200,000 kilometers per hour and will be leaving the solar system permanently. We couldn't catch up to it with current technology, even if we launched immediately. Do we just watch it go, knowing we had a chance to learn from something built by another civilization and we weren't ready? Do we point every available telescope at the sky, searching desperately for more interstellar visitors, hoping the next one is slower or comes closer? These are not hypothetical questions anymore. We're 3 weeks from potentially facing them, and I don't think we're ready. Not because we lack the technology to observe or analyze. We're actually quite good at that. We're not ready psychologically, socially, philosophically. The idea that an artificial object from another star system could pass through ours, that we could detect it and study it, that we might realize what it is only as it's leaving, challenges fundamental assumptions about our place in the universe. For all of human history, we've been alone, or at least we've acted as if we were. The question of extraterrestrial life has been abstract, theoretical, something for late-night discussions and science fiction, but not something that affected policy or planning or how we see ourselves. If 3I Atlas is artificial, that changes. Suddenly the universe is not just vast and empty. It's populated. Other minds exist, or existed. They built things. They sent them into the void, just as we've sent Voyager and Pioneer. And one of those things found its way here. The timing is strange too. 3 interstellar visitors in 8 years, after none in all of recorded history before that. Is that just a coincidence of when we developed detection capabilities? The Atlas system, the sophisticated tracking networks, the telescopes powerful enough to characterize these objects, all came online recently. Maybe objects like this have been passing through forever, and we only now can see them. Or maybe there are more of them now. Maybe we're entering a region of the galaxy where interstellar traffic is higher. Maybe something happened recently in cosmic terms that ejected more material from other star systems into the general interstellar medium. A wave of star formation and planetary system disruption, spreading out from some galactic event. We're seeing the leading edge of that wave now. Or, and this is the speculation that keeps astronomers up at night, maybe they're not random. Maybe Oumuamua was a scout, surveying the solar system, sending back data to wherever it came from. And 3i Atlas is the follow-up, a more sophisticated probe, designed based on what Oumuamua learned. That would explain the perfect planetary tour trajectory. It's maximizing observation of the most interesting targets based on prior reconnaissance. I want to emphasize that this is speculation, not scientific consensus. Most astronomers think these objects are natural, that we're just seeing the normal distribution of material ejected from other planetary systems over billions of years. The strange behaviors have natural explanations we haven't discovered yet. Everything fits within known physics and chemistry if you allow for compositions and structures we haven't encountered before. But a small and growing number of scientists are willing to consider alternatives, not because they want to believe in aliens. Most scientists are deeply skeptical of extraordinary claims. They consider alternatives because the evidence, while not conclusive, is suggestive enough that dismissing the possibility entirely would be unscientific. And if there's one thing that defines good science, it's following the evidence wherever it leads, even when it leads to uncomfortable places. Avi Loeb has taken significant professional risk by publicly advocating for the artificial hypothesis. He's been criticized, mocked, accused of attention-seeking, but he's also been honest about the data and what it does and doesn't tell us, and he's willing to be wrong. That's important. Science progresses not by being certain, but by testing ideas and accepting when they don't work out. If 3i Atlas turns out to be a natural comet after all, Loeb will be the first to acknowledge it. He's said as much repeatedly. He's not invested in being right about aliens. He's invested in investigating the question properly. And right now, that question is, could this object be artificial? The answer might be no, but we won't know unless we check. So we wait. 3 weeks, maybe less if 3i Atlas emerges from solar conjunction earlier than predicted, which would itself be interesting because it would mean our trajectory calculations are off. The telescopes are ready. The observation plans are finalized. The scientific teams are assembled. And around the world, millions of people who never thought much about astronomy are suddenly paying attention to a comet. Whatever happens, this is a remarkable moment. We live in an era where we can detect objects from other star systems, study their composition, track their trajectories, and seriously discuss whether they might be artificial. That capability emerged only in the last decade. Before Oumuamua, interstellar visitors were theoretical. Now they're observable, analyzable, real. And 3i Atlas is the most interesting one yet. Ancient beyond measure, chemically bizarre, behaviorally anomalous, perfectly positioned for planetary observation. Hit by a massive plasma storm at exactly the moment when we can't watch. If someone designed a scenario to maximize scientific interest and speculation, this would be it. In November, when the data comes in, we'll know more. Maybe not everything. Maybe we'll have more questions than answers. But we'll know more than we do now. And that's how science works. Small steps, incremental progress, building understanding piece by piece. Sometimes you get lucky and make a giant leap. Usually, you just add another data point to the growing collection. But every once in a while, very rarely, you stumble onto something that changes everything. A discovery so fundamental that history divides into before and after. We might be living through one of those moments right now. We might look back at October 2025 as the month when everything changed, when humanity's place in the universe shifted from speculation to certainty. Or we might look back and see it as an interesting but ultimately routine astronomical event. A weird comet that taught us about the diversity of planetary systems, that expanded our understanding of how materials circulate through the galaxy, that gave us better tools for studying future interstellar visitors. Either way, we're paying attention. We're asking questions. We're collecting data. We're doing the work of science, following the evidence, testing hypotheses, remaining open to possibilities while demanding rigorous proof before accepting extraordinary claims. And in 3 weeks, 3I Atlas will emerge from behind the sun, and we'll start getting answers. The waiting is almost over. The mystery is about to resolve, one way or another. And I, for one, can't wait to see what we find. This object, this ancient visitor from a stellar neighborhood we'll never see, carries within it information about worlds and times beyond our reach. Whether that information is purely chemical and physical, the natural record of formation and evolution, or whether it includes something more, something intentional, something built, we're about to find out. And that makes this one of the most exciting moments in the history of astronomy. Whatever we discover, we'll have learned something profound about the universe we inhabit. We'll have taken another step toward understanding our place in the cosmic story. So watch the news in November. Pay attention when 3I Atlas reappears. Watch for the first observations, the preliminary reports, the scientific papers that will follow. This is history happening in real time. This is the moment when we might, just might, learn that we're not alone in the universe. Or we might confirm that comets from other star systems are weird and wonderful and teach us things we never expected, and that the universe is even stranger and more interesting than we imagined, even without aliens. Either way, it's a pretty good outcome. Either way, we learn something amazing, and that's what makes this so compelling. We can't lose. No matter what 3I Atlas turns out to be, we gain knowledge. We expand our understanding. We push the boundaries of what we know about the cosmos. So here's to 3I Atlas, whatever you are. Thanks for visiting. Thanks for showing us how little we really know. And thanks for giving us the opportunity to wonder, to question, to explore. That's what makes us human. That's what drives us forward. And in 3 weeks, we'll know a little bit more than we do now. That's worth celebrating, no matter what the answer turns out to be.